Okay, so vertical number lines. We've looked at horizontal number lines and the way we use those to represent arithmetic operations. All right, so on a horizontal number line here, the positive numbers are to the right of 0, the negative numbers are to the left. So why do we need a vertical number line? And what is its relationship to a horizontal number line? All right, so let's take a horizontal number line and set it aside. Now we take another number line, same concept, all right, and we can turn it, all right. So now we put 0 in the middle, we count up, 1, 2, 3, 4, we count down, -1, -2, -3, -4. So now we have a number line which has been rotated 90 degrees, 0 is in the middle, and up is positive, down is negative. Numbers get more negative going down, more positive going up. And we use these also to represent arithmetic operations. But the question is why? Why, if we have a horizontal number line, why do we also need to have a vertical number line? And the answer is this. As students advance their algebraic thinking, we need to start using the Cartesian plane, or we call it the XY coordinate plane. All of those are ways to talk about it. But basically, it is a horizontal number line and a vertical number line which cross at their zeros, okay? And this creates a two-dimensional number line, basically, that we call the Cartesian plane. The conventions that students need to learn then come from the idea of the horizontal number line, where negatives are on the left, positives are on the right, zeros in the middle, and the vertical number line. Positives are up, negatives are down. Okay, so in the Cartesian plane, any number in the plane can be represented by an ordered pair of numbers. So if I come up here and say this point is represented by the 1 on the horizontal line, and I put a little comma and I say it's represented by a 3 on the vertical number line, now I've got a way to basically write an address for every point on the Cartesian plane, where the first number is horizontal distance from 0 and the second number is vertical distance from 0. So then we can divide the Cartesian plane into quadrants and call this the first quadrant. All pairs of numbers here, both will be positive because they're positive horizontal, they're positive vertical. Second quadrant, all horizontal numbers are going to be negative. So here I have a number, -3, +1, okay? -3 on the horizontal axis, +1 on the y-axis. That's coordinate 2. So negative, negative. In the third quadrant of the Cartesian plane, all of my numbers will be in the negative direction on the horizontal axis and the negative direction on the vertical axis. So negative and negative. And then finally in quadrant 4, all of these numbers will be positive on the horizontal axis, negative on the vertical axis. And so having these two number lines cross, is a very powerful way to represent relationships between things that are measured on one axis and the other. And also then students have to learn this convention about down being negative and left being negative, so that when they have these ordered pairs, they can recognize things like what quadrant is the number in if both of the numbers in the ordered pair are negative. And that's why we need vertical number lines.